So what are you guys?
We're part of the Swartwood family!
And you guys real Swartwood students?
Hell yeah!
Hi guys, thanks for coming out to the review. I just want to do a quickie poem because we didn't get a chance to do this during the review because I know we had to speed along and do some of the topics toward the end, right? So I just want to add one little thing about elastic collisions. Okay. I think everything I wanted to say about inelastic collisions we did in the review. Okay? It's just for the elastic guys. Remember there are two sets of equations. There was one that said this, 1/2 m1v1 squared plus 1/2 m2v2 squared, right? Is equal to 1/2 m1v1 squared. I'm going to change this in a second, don't worry. 1/2 m2v2 squared. Obviously the difference is left hand side was initial and the right hand side was the final. So I'll just put that with bars. Okay. Or note that with bars. Okay, so we have this setup. Remember, in an elastic collision, the kinetic energy is conserved because everything's pretty. Nobody deforms anybody, nobody gets crunched, everything's nice and pretty. Okay, we also have momentums conserved. So m1v1 plus m2v2 is again m1v1, m2v2. Okay. With the bars. So the bar is just saying initial versus final. Okay, no big deal. And the one that I talked about was, if you wanted to derive a relationship between them, you can kill the halves, make life easy, right? I also kind of want to do this, I just want to group terms. So I have the M1 guys over here, and I have another M1 guy over here, so maybe I want to collect them, bring them over. Okay, you don't have to do this, but this is what I did, I think. So we're going to bring the M2s and bring them over as well. Okay, this is pretty fast, because I'll have M1s on both sides, so I can factor out. M1 is V1 squared minus V1 bar squared. Okay. The right-hand side, we're going to get something like M2. So we're going to factor him out. V2 bar squared for this guy. And then since we're bringing this guy over to the right, he'll become a negative. Negative. The M2 is already factored out, so V2 squared. Okay. No big deal. We can do the same thing with this guy. So I'm going to collect these terms very quickly. We'll try to. You get M1 and it looks like V1 minus V1 bar. In fact, you can see it parallels this guy, right? Same thing. We're going to bring this guy over. We're going to this side. So we have M2 following basically the same pattern. V2 bar minus V2. Okay. No big deal. The thing is that we want a relationship where we can simplify things down as much as possible. Those M's are annoying because they're kind of in the way. So why don't two guys are equal here. If you divide the left by some number and the right by an equal number, you should get the same answer. You guys agree? So I'm going to take two equal guys, divide on the left by this number, divide on the right by this number, and these two numbers are the same. So if you divide left and right by the same number, you should get the same answer. So the M's will die. On the left-hand side, I need to do a little bit of factoring, but do you remember from way back when this guy factors nicely as V1 minus V1 bar times V1 plus V1 bar, right? So the difference of two squares, okay. This is actually the difference of two squares. So this guy factors into this. I'm going to take this away. And you can see this term here, the minus term, will cancel this guy, right? So on the left, we actually end up with V1 plus V1 bar is equal to, similar pattern on the right, we'll get V2 minus, or plus, sorry, V2 bar plus V2. Doing the same sort of trick on the right-hand side. Okay, so now we got this. This is what I talked about. Then a student pointed out, coming off a break, she mentioned that the form the prof gave you looked more like this, but it's the same thing. The prof collected the initial terms on the left and put the final terms on the right. So this is the same statement, okay? If you look at this, this always holds, but what I meant by you should have some relationship where the masses are involved. So let me clarify what that means. If you look at this guy, I know the difference. So if I give you the initial conditions, you know the difference, which means you would know the difference in the final conditions in terms of velocity, right? Okay, but you don't actually know what these guys are. Like, you know, if I gave you this and this, you can find out maybe the difference is 5. Then you know the difference between the final guys would also be 5, but you don't know individually what these are. So what I mentioned during the review is, this is not enough info, you need to know information about the masses, right? So what did I mean by that? I meant, if you want to figure out exactly what these guys are individually, you have to have some information about the masses. There is an ugly formula that actually relates all of that at once. So I think the best way to go is to go with what the prof gave you, but then use an additional equation. Again, this is what you probably did in class. Like, for example, this one. Oops. Okay, final, well, here in this example, we call it V bar, where not only are you linking up the velocities, you're also linking up M1 and M2. So you're linking up the masses. So once I have information about the masses and the relationship about the difference between these sets of velocities, then I can figure out everything. Like I can actually compute for you V1 bar and V2 bar, right, in terms of my initial conditions and in terms of the masses given. Okay. But does everybody see what I mean? So on the exam, I go with this and I go with that. I need both pieces of information before I can get final answers here. Okay? This difference relationship always holds, but I need both pieces to get a final answer. Okay, that's not too bad. By the way, I don't think anybody cares, but you could do this. Everybody can do this. It's just really tedious. You could try to solve for one of these. For example, a V2 bar. I can take V2 bar and I can try to write it in terms of V1 bar and V2. I'm sorry, V1 and V2. The only problem is I have V1 bar, which I don't know, right? So I want to solve for V2 bar in terms of these guys, and I want to somehow get rid of this. To get rid of this guy, I can use this equation and solve for V1 bar. And if you plugged all that crud in and worked it out, you can actually get a general equation. Again, I don't think that general equation is worth your time. I think you go with this, or you go with that, and then you're good. Okay? So, if you did do that, it would turn into something horrendous. So I think it turns into something like 2m1 m1 plus m2 times v1 plus, I think, m2 minus m1 over m1 plus m2 times v2. You should double check me, because without fully deriving it, I always tend to mess up the factor top bottom. But you can actually get a general form answer like this. And then for v1 bar, I can actually get the answer by flipping them. So 2m2, m1 plus m2, v2 plus m1 minus m2 over m1 plus m2, v1. But these are horrific. Okay? So anyway, what's the point of this? I wanted to do a problem with you. A problem that I think would be fair for the exam. And where we would use both pieces of information. Probably the prof's already done something similar to this, but it doesn't hurt for us to review it one more time. Okay? So I want to use this statement, v1 minus v2 is equal to v2 bar minus v1 bar. And I want to use conservation of momentum. Okay. And I want to do a special case. So here's our special case. So let's play cool. I want to take a cue ball of mass m, and I want it moving at a velocity v. Okay? You can make them concrete numbers if you want, but I'm going to say this, the prof gives you. Okay? Then I want to have this ball here. Okay? Just hanging out. So the cue ball is going to smack that ball. The masses are the same. And I want this collision to be perfectly elastic, or elastic, same thing. And I want you to tell me basically what's going to happen. Well, you played pool before, so you know what's going to happen. This guy's going to come along and smack this guy. Oops. Right? Probably what's going to happen if we do it right is this guy's going to stick and just sit there. So we know his final velocity, v1 final, is going to be 0. Then we know the other guy is going to get smacked and run off to the right. And if it were really nicely elastic, what would happen? Probably you would figure, since this guy had an initial velocity of v, this guy, v2's final velocity, it would also be v. Be the same number. Does that make sense? V comes in at 10 meters per second, not really fast. They smack this guy, he should stop, and this guy should move off at 10 meters per second. Okay, so let's actually do it and see if we get the right results. Okay, so we'll start off with this equation. So I think the setup is, you know, v1, so let's label stuff. So there was mass 1, which has a mass of m, and a velocity v1 of just v. So those are numbers they gave us. Okay. There is mass 2, has a mass of 2, and initial velocity v2 of 0. Okay, those numbers they gave us. So let's plug it into this equation and see what we get. Okay. So up top, I have v1 coming in is just v. I'll make to the right the positive direction. We have v2 actually being 0, so minus 0 is equal to v2 bar minus v1 bar. Okay, there's nothing wrong with that. But as you can see, so I know the differences in these velocities is equal to v, right? But I don't actually know what these numbers are. So I need to incorporate somehow this information, right? I need to know information about their masses. Here it's going to be particularly simple, so it won't always be this pretty, but in this case we have the advantage of knowing the masses are the same, right? The cue ball is the same as whatever ball it hits, like the 8 ball, for example. Okay? So we can make this, in fact, we can simplify this equation, because the masses are all the same. I think I can kill it. Right? Prof can easily give you a problem where you can't do that because the masses are different. But here it's going to be pretty. So then we get V1 plus V2 is equal to V1 bar plus V2 bar. Okay. V1 was really nice. It was just V. V2 we said was 0. And now we get this. Okay. Doesn't look like we made a whole lot of progress, but actually, this is all we need. Okay. So let's look at this. This equation says V is equal to these two guys. This equation says V is equal to those two guys. So why don't we set them equal? If we set them equal, we get V2 bar, minus V1 bar is equal to V1 bar plus V2 bar. Life will be easy because we can kill these guys. They go away. Now you get the seemingly innocuous statement, negative V1 bar is equal to V1 bar. But how many numbers are equal to their own negative? There's only one number, right? It's got to be 0. So what that tells you is V1 bar is 0. That's exactly what we predicted, right? Remember we said if we had this ball here and it ran over this way and smacked this ball here, we would figure after the collision, this guy would stop dead in his tracks, right? And the other, he used to be still, but now he'd move off, right? So that's what we predicted. This guy smacks this guy, stops dead in his tracks, the other guy picks up speed. Okay, so at least the first part is confirmed. Okay, we also guessed that if you came in with a velocity of v, after the smack, the other guy would also have a velocity v. Right? Okay, let's confirm that. Pick any equation you want. I think, why don't we just use this one? Okay, so let's use that one. So, let's clean this up. Sorry. Right now we have this piece of info, which is what we predicted. Let's finish this off. So v is going to be equal to v2 bar minus v1 bar, but we know v1 bar is 0. So what's that tell you? V is equal to v2 bar. So that's exactly what we expected. The first guy is going to stop, and the second guy is going to go at the speed the first guy had coming into the collision. Okay, that's it. Most likely in the exam, most of the problems are going to run like this. You start with that equation that the prof gave you. You start with your knowledge about momentum. It's elastic, right? So here's a relationship linking the velocities. Here's one that links the velocities and the mass, right? Or the masses. Put them both together, information about the velocities and the masses, and then you can figure out what happens in the end.